Okay, I'll start over. Hey everyone, I'm Adam Crane. Again, they call me a site reliability engineer here. I don't really know what that means anymore because we do a bunch of everything. So, but today I'm going to be talking about GraphQL and one thing, I don't filter my Twitter feed and I don't use a work account. So if you want to get connected with me, just talk to me after the talk and get my handle. All right, so, as engineers in the modern era, we are collecting and processing more data than ever before. And when we take on a new engineering task, our goal is usually data-oriented. We're either surfacing some existing data in a new way, or we're generating some new data and need to get that out to someone who wants to consume it. And just to clarify, because it means a lot of different things to different people. Ultimately we will end up with some unit of modularity of data and code tied together, and that's what I'm going to call a service during my talk today. So it doesn't mean anything more or less specific than that. Services come in all different shapes and sizes, and your application at your company might fall really anywhere on the microservice scale, and that doesn't really matter for the purpose of this talk. But as we connect more and more sources of data and more services, the need for a common language and a common way to easily pull data in and out of these things becomes more necessary. Especially if you're like Twitter and you have thousands of microservices that are all tied together. So for instance, there are different ways to deal with this problem. At Twitter we have something called Strato. It's a virtual database complete with its own query language that brings together all of the site's core data and even lets the developer stitch together queries into streams, joins, fan-outs, etc. without having to write a service at all. Mike Solomon actually covered this last year at Scale by the Day, and I hope you checked out his talk yesterday about transpiling GraphQL. Very relevant. But I'm not going to get into that because he did such a good job with it. But even Strato, at the end of the day, is a specialized system, and we have some fat clients and other things that need to talk to it. So ultimately we have to get data in and out of that in more universal and easier ways, for little things like the Twitter API. Former tweet now, but at the time of his talk, Tom Ashworth last year gave a great talk about how Twitter uses our GraphQL API as an alternative to REST. So check that out. It's actually in the links at the end of the presentation. But for now, let's get back to thinking about services and data. So we've got some data we want to show to the world. How do we describe that data in a way that consumers can easily understand? Not only what's available, but also the relationships between the elements of our data set. And enter GraphQL. I don't think I can do a better job at telling you why you should use GraphQL than some other people like its creator, Lee Byron, have already done excessively in his blog posts and tweets. So I have a link to some of his talks at the end of this, and I encourage you to go check it out. Instead, I'm going to focus on how you can use GraphQL as a foundation for starting a new service and exposing a new data set, and some of the unique tools that it can provide to speed up your development process and make your life easier, hopefully. I had originally put a bunch of explanatory content in this presentation. Talking about schema design and why it's nice and all these other things, but after seeing the talks yesterday, I realized the skill level at this conference is really high, and you guys probably want to get down to business. You've probably at least heard of GraphQL, so I'm really going to focus just on some tips and tricks and power moves that you can use, and if you haven't crossed the threshold into maybe trying out GraphQL, maybe some of these things you haven't heard before, and they might take you over that edge. All right, so the format of this I adapted last night to be more of a problem and solution type format, so let's roll with that. All right, so first thing is we need to expose our data. And the winning combination that we have found here at Twitter is Sangria plus Finatra. You know, this conference doesn't have Scala in the name anymore, but I know most of you in here know Scala, so I'm going to focus on Sangria a lot. That is basically the de facto open source Scala GraphQL library. And Finatra is our library that we use predominantly here at Twitter to write all of our server processes. Essentially, all of our internal servers are running on that these days. So it's fully open source, and they go really well together. There is not built-in integration between the two, but you know, when we needed to do this at Twitter, it took about a day and about 20 lines of code to get that working. Finatra uses HTTP and Thrift out of the box, but you can actually get it to run on almost any protocol, and GraphQL itself is protocol agnostic, so whatever your use case might be, you can try out these two. All right, so the next thing you might run into is, you know, now we have a server, we have some GraphQL schema that we're exposing with our API, pretty much out of the box, like I said, in about 20 lines of code. And we're describing our data. Our customers can see our documentation of our schema just by hitting the GraphQL endpoint that we have set up because it's self-documenting. But we need to enter the next phase of developing an application, and that is generally about testing out our API, handing it over to maybe some other developers, like front-end developers that we're working with, and basically, in the previous life, you know, if you're using a REST endpoint or something like Thrift, you would have to recompile your application, rebuild it, deploy it, send it to your front-end developer, give them, you know, all of the documentations you wrote on your REST endpoint, which you did do, right? With GraphQL, it's much easier because there's this magical thing called graphical or GraphQL that Facebook has made that basically comes bundled into every GraphQL server, and actually a few slides back, I have a link here at the bottom. I encourage you to go check that out during the talk. Or if you just Google Star Wars API, GraphQL actually hosts this under their GitHub account. That's a fully running instance of Graphical that you can play around with while I'm talking. But yeah, Graphical is amazing. I would categorize it as a game changer. You can kind of see it in action here. There is, there we go. All right, so one of the simple features that it provides that was actually something that I didn't think would be so important is tab completion. John Preddy yesterday, when he was talking about Fury, spent an entire slide and probably a minute talking about the wonder of tab completion, and I totally agree with him. So in Graphical, you can tab complete fields, they auto-populate, and basically you can explore your entire API this way without having to find any relationships in your data ahead of time besides you know, some very basic ones. Basically, in a REST configuration, you need a giant matrix of relationships. You have to put those in endpoints. You have to figure out whether they're fields, whether they're a new endpoint, etc. In GraphQL, you can have that at your fingertips in just a few seconds. And something that you're going to find out once you start exploring your API like this very quickly is some queries take longer than others. Some fields take longer than others. And a very nice thing that Sangria provides and GraphQL provides in the form of extensions is this tracing framework. So Apollo is a very popular GraphQL client, and they have a standard tracing format that you can plug into Sangria and GraphQL and get these histograms of P99s on your data right here while you're querying it, which is really, really nice. And try it out. All right. So we have, let's keep moving. We got our schema, our server. We have a nice graphical client to drive development. That kind of acts as the watering hole between front-end development and back-end development to sync up at every point during a process. We started exploring what's possible with our API. We can connect our data in arbitrary ways. Life is good. But pretty soon we're going to run into some problems once we start actually using this to get data in and out at volume. One that's commonly cited is the N+1 problem. I would categorize that as not actually a problem because basically every GraphQL library has a thing called Resolver or data loader framework. And the cool thing about that is because our query is coming in as a graph, technically it's being represented as a tree of properties in our query. It looks a lot like JSON. It's just a big map. But because it comes in as a tree, we can actually traverse that tree, figure out the dependencies between our data that we need to load. What can be fetched in parallel? What needs to be fetched before another field can be loaded? What is dependent and what is not? And by doing that, GraphQL library can handle all of that optimization without you doing anything. Sangria has this in the form of something called resolvers, and they have a very nice resolver that comes out of the box called Fetcher, and it can handle things like batching, caching, deduplication, parallelization for you right out of the box. All you need to do is provide an ID for an object, and it's pretty much ready to go. If you're using a relational database, you can also describe things in terms of relations instead of unique IDs. All right. Just a small note, if you're using key value storage, this is super easy because you pretty much have a unique ID right out of the box for every value, which is the key, or some map of your key. Cool. So we're only like 5 slides in, and I feel like we're really rolling with our GraphQL service. We can already do a lot of stuff. We're like tracing, optimizing, front end and back end is living in harmony. We probably need to start thinking about some of our clients. And one of the destinations that any GraphQL data is going to go is typically going to be some type of reactive client. So a front end, a GUI, it's running React maybe, possibly Vue. It doesn't really matter. What matters in this case is that, again, some things load fast, some things not so fast. Images are a great example, binary data. Maybe we have very large fields that we don't need to render at the beginning, but we do need to have some to start drawing our application while those are loading in the background. And in the past, like with REST, or perhaps some kind of RPC system, the way we would do that, split up our queries. Query the fast stuff first, and then maybe in parallel query the slow thing, handle it that way. And the thing is that kind of goes against a lot of the GraphQL principles of putting all our data in one place, putting all of our queries on one endpoint, right? So we don't actually need to split up fast and slow queries when we're using GraphQL. Instead, we can use another cool feature of the language, which is called directives. And one of the most useful directives is this one right here called defer. And if you tag a field with defer directive, it's pretty much like a decorator for a field. You will get the main body of your response back first, and then later you'll get what looks like this, which is called a patch response. So instead of being the entire tree, you basically get a path to a single item, and the data contains the value of that single item. So these can start flowing in asynchronously to your application. All right, so the one tricky thing, not all of the directives are totally standardized yet, but most of them that have been around a while, like defer, are pretty well implemented across all of the different GraphQL libraries, so don't be afraid of using them. And in Sangria, it's very easy to use defer. You basically just feed it a feature and it does its work. All right, so we got a few other things that we need to watch out for. We know about directives and partial responses are possible, but That's great for expensive fields. What happens when we have a list, though? That's kind of another type of data we need to watch out for a lot of times. One reason is we don't know the size of the list before we get it. Unless we fetch some data in a round trip, or we get that data somehow ahead of time, we really have no idea how big it's going to be. And in the beginning, the way to deal with this was with cursors and pagination. Like you're using a SQL database, et cetera. You fetch the next 10, the next 10, the next 10. And that's still valid, but it's kind of solving a different problem, which is indexed data. We don't really care where we are. We just want to treat this as a stream. We want to get it all. We want to get it in order. We want to get it eventually. That's really all we care about for a lot of data. And so to solve that problem, we have the stream directive. And it's pretty much exactly the same as defer, but instead of getting patch responses for fields, we get a patch response for an individual index. And you can see as part of the path, we get an index value back instead of just the field name. So cool. We're like 7, 8 slides in. We've been able to do a lot of different things just inside of the language of GraphQL. And hopefully our service is up and running, people are using it, and unfortunately that can cause problems in and of itself. Anytime you have users that can write their own queries against your service, they're probably going to do bad things that you've never even capable of imagining. Query patterns are very easy to make world-ending fan-outs inside of a GraphQL query. Because you can arbitrarily relate any data to any other data, this is a simple example from the Star Wars API, but we're getting the name of all of the residents of all of the planets of every film that every pilot of a starship has ever been in. So, and with Twitter, it's even easier. Basically followers of followers of followers, and very bad things start to happen. So how do we deal with that? With GraphQL, the reason you don't see that on some other things is because you have to get data back before you can use it to make more queries. With GraphQL, that's not the case. You can define these dependencies right in your initial query. So Sangria and most other libraries have a few ways to deal with that. One is query complexity analyzer in Sangria. It's about this easy. It's like 2 lines. You can basically weight queries or fields with arbitrary parameters, arbitrary calculations for weight. Add those up and very easily make a filter for queries that are too complex. And you also have depth limits available, which is basically just how deep is your tree. And that will end up looking something like a fast failure. That query will get parsed right at the beginning, and a rejection response will be sent back. And the reason that that's the case, instead of maybe like a partial failure, if your query is too deep, or partial response, is GraphQL really likes to be explicit about when there's a bad query. In this case, we didn't fail to fetch the data for a client. We were really telling it like, no, your query is not okay. We want them to very explicitly know that. So cool. People are using our application. We've got everything under control. We're not getting paged every 5 minutes anymore. But we want to make things even better. And caching is going to come into play. With HTTP, it's pretty easy to do caching because in REST, every resource is tied to a URL. You can use that URL as a unique identifier for an object. Anything that understands HTTP can know enough to do some form of caching. Like an HTTP header, we have cache control. We have things like e-tags, and anything that understands HTTP can implement that. In GraphQL, we have to try a little harder because we only have one endpoint. Objects are inside of our protocol, so we have to use our own caching policy, and Sangria and Apollo and clients all handle cache control extension that has been pretty formalized. So you can define your own cache control policy per object inside of your GraphQL response. And I would like to talk about that more, but basically, I am running out of time. I do recommend, if you're going to try out GraphQL, use a client. You need a client to handle a lot of these extra features and extensions, like properly treating caches properly. And they have a lot of other great features too, but I won't get into that. The last thing I want to talk about is, assuming you've done everything correctly, hopefully people are going to be really happy with your GraphQL endpoint and your new service. You might proselytize that around your organization, spread the good word. Maybe a lot of people are using GraphQL now. And so, maybe what started as one GraphQL service is now 20 or 25. And again, kind of the saving grace of GraphQL, its real unique feature is bringing things together and unifying them and really providing clients with like a single place to see data. And that's super easy to do with GraphQL, thanks to some conventions called schema stitching. Every library implements this a little bit differently, but essentially you point to another GraphQL server or a flat file of the schema, automatically gets merged with yours, and you can use a thing called type extensions, which is in the object-oriented language, you just add a method to a type. This is the same thing except for data relationships. So what could have been a terrible problem of having data spread out all over your organization is now a tool you can take to your advantage. GraphQL has introspection abilities, and using that to perform automation, much like the transpiling talk earlier, is something I encourage everyone to try to do because the possibilities have not been realized yet. All right, and that's basically it. I was going to talk about implementation that we use, where I learned a lot of these things here at Twitter, but I think I'm out of time. So if you have questions about it, it's about visualizing network data, and we process a lot of it. So come talk to me afterwards. Yeah, there's a bunch of links, so check the PDF and see what other people have written about this, even at this conference. And I'd like to thank everybody, especially Julian, my partner in crime. He helped me a lot with this talk. So thanks, everyone.
Thanks a lot, Adam. I know I learned a lot about, especially for queries and things.
Sure.
But we do have time for maybe one or two questions.
Hey.
Hi. Do you have any knowledge, can you compare Sangria to GraphQL Java, especially in the cases where developers are not as Scala savvy as they're
I see. Unfortunately, I do not have experience with GraphQL Java. Sangria is, we're such a Scala-heavy shop. It really gets a lot done. One of the things that's nice about Sangria is it basically implements every optional feature, all of these directives, things that are not standardized yet. I don't know if GraphQL Java is the same way. That's something you might want to look into if you're trying to decide between the two. Yes?
Does Sangria now support relay connections?
Sorry, say that again?
Does Sangria support relay connections?
Relay connections?
Yeah, because I remember having to implement them by hand.
That's a good question. We've used Apollo internally a lot. I haven't tried implementing connections with Relay recently, so I can't really tell you the state of the art with that. But I know they have been working on building out Relay support in that recently, so there's a good chance.
All right, and
Oh, sure. Okay.
Thanks again.
Thank you.